weaving processes dynamically with top command. So while the ps command can reveal a lot about what the machine is doing, it provides only a snapshot of the machine state at the moment of the ps command is executed. To see more dynamic views of the machine's activity, we use the top command, like this, here. So the top command displays a continuously updating, by default, every 3 seconds display of the system processes listed in order of process activity. So the name top comes from the fact that the top program is used to see top processes on the system. So the top display consists of 2 parts: a system summary at the top of the display, followed by the table of processes sorted by CPU activity. So here, the system summary contains a lot of good stuff, as you can see here. Let's actually understand what these are. So here we have top. So this is the name of the program here. And here, as you can see here, we have, actually, let me get my marker here so you can see better here. So here, as you can see here, this is the current time of the day. This is the current time of the day, right? And we also have the, oops, let me here. We also have the up 9 minute here. Obviously, it says this is a called up time. So it's the amount of time since the machine was last booted. So in this example, the system has been up for 9 minutes. And we also have this user here. This is this means that there are 1 logged in user, and as you can see, it's a Typhoon here, which is my main user account. And we also have the load average here, load average. This load average refers to the number of processes that are waiting to run, and that is the number of processes that are in a runnable state and sharing the CPU. So 3 values are shown here, so each for a different period of time, and the first is the average of the last 60 seconds. So the next here, this is the last 60 seconds, average of last 60 seconds. The next is the previous 5 minutes, and the finally here, so this is and 0.03 is the final of 15 minutes. So values less than 1.0 indicate that the machine is not busy. Here, as you can see here, my machine is not busy right now because our values is less than 1. In this case, 0.12, 0.10, and 0.3. And as you can see, it changed to 0.10 right now. And we also have the tasks. The tasks here, tasks. So this is obviously, this says that the tasks is summarizes the number of processes and their various process status. And we also have the CPUs, and let's actually, this task, as you can see, the 192 is total, 1 is running, 191 is sleeping, 0 stopped, 0 zombie. And here, as you can see, these are the tasks that I use in my system. And we also have the CPU. So this CPU, this row, describes the character of the activities that the CPU is performing here. So now I will explain what these tabs and information that CPU tab provides us. The firstly, here, as you can see here, US that's written here. So the US that's written here means that here, in this case, it's 0.6. 0.6% of the CPU is being used for user process. Here, as you can see, 0.5, 0.3, and so on. And we also have CI here. So this is, and right now is 0.8, 0.3 here. So this is the percent of the CPU is being used for system, kernel. So it's a kernel. And we also have NI here, so 0.0 NI. So this 0.0 in this percent of the CPU is being used by nice low priority processes. So as you learned what's the nice and low, in previous lecture, actually you learned about high priority and low priority processes in previous lecture. So in this case, it's my CPU is used to its power 0.0% for low priority processes. And we also have this here, in this case it's a 97.3 ID. This is the percent of the CPU is in idle mode, like you turn on your car and it's just in an idle mode. It doesn't do or go to anywhere. And we also have 1.0 VA. It's now probably 0.0, and here it's going to be 1.0. So this is a percent of the CPU is waiting for input output. You also learned what the input output is in previous lectures. And we also have mem. So this is obviously this shows how physical random access memory is being used here. This is 3,914 total, 2,658.93, 1,415 used, and 477 is buffered and chats. And we also have the swap tab here, swap information here. This swap shows how swap space or virtual memory is being used. In this case, the total swap memory is 1024 with 1 gigabyte and not used here. As you can see, total is right here, and there's all of them is free. So 0.0 is used right now, and avail mem here. So the top program accepts a number of keyword commands. So the most interesting are the h command here, h keyword here. Let's actually try that. H here. As you can see here, with h command, this h command displays the help screen, and q command here, q keyword. When you press the q keyboard. Q key in your keyboard, you will get this. You will get here, as you can see here. Now we queued from the top command here, and let's try it. H again, and toggle v force view, and here v, here q v. Here, as you can see here, we have several commands that we will use in next lectures here. So here. Clear. So both major desktop environments provide graphical applications that display information similar to top in much the same way that Task Manager in Windows works. And the top is better than the graphical versions because it is faster and it consumes far fewer system resources. After all, our system monitor program shouldn't be the source of the system slowdown that we are trying to track. So in next lecture, you will learn how to control the processes in Linux. So I'm waiting you in next lecture.